The ordinate and abscissa of the diagram to duplicate the isobaric process of the ideal gas is as hyperbola respectively. The answer number C, the temperature and density. So hyperbola of the diagram, ideal gas diagram will be converted. That hyperbola is mentioned. It is showing temperature and density. Next, this is the question number 15, and question number 16 is consider the following statement. Here, the entropy of the pure crystalline substance at absolute zero temperature is zero. Point number 2, the efficiency of reversible heat engine is depending on the nature of the working of substance and the depends only on the temperature of the reservoir between which it operates. Point number 3, Carnot theorem Carnot's theorem state that all of all heat engine operate between a given constant temperature source and a given constant temperature sink. None has higher efficiency than a reversible engine. Which of the statement is correct? So I think all are correct. The entropy of the pure crystalline substance at the zero temperature is zero. Means entropy of the pure crystalline substance. Suppose there is a substance, that substance is the crystalline, and that is the pure, and that entropy at the absolute zero temperature, its entropy is also zero because temperature is zero. So entropy also zero because the temperature is depend on the entropy, and this is the pure crystalline substance. So that's why the temperature at the zero temperature, the entropy is the zero. The efficiency of the reversible heat engine is dependent of the nature of the working substance, and it depends only on the temperature of the reservoir between which operates. Means here is the efficiency. We are talking about the efficiency. Uh, the efficiency of the reversible heat engine. It's depend on the nature of the working substance. It's depend on the nature of the working substance. Which substance we are adding there? It's depend on that. That depends only the temperature. Means substance and temperature. It is depend on the substance and temperature of the reservoir between each operate. So so yeah, this is also correct sentence because if efficiency of the reversible heats is depend on the nature of the working substance, and the depends on only the temperature of the reservoir. So working substance nature and reservoir temperature, on this the efficiency is depends. Point number 3, Carnot's theorem state that all heat engine operate between the constant temperature. All heat engine is operate between the constant temperature and resource and source of the given constant temperature sink. None has the higher efficiency than the reservoir reversible engine. So this is also correct. The Carnot theorem state that the all heat engine operate between the given constant temperature source and the given temperature sink. Same temperature source and temperature sink, in between the heat will be generated. That is the statement of the Carnot theorem. So which statement is correct? So all 1, 2, 3 are correct. Question number 17. An engine works on the basic Carnot cycle operating between the temperature of 800 Kelvin and 400 Kelvin. So there is the T1 and T2 is given. If the supplied 100 kilowatt, Q is given is 100 kilowatt, the output is, so Q is Q into, so when we are creating the output, W equal to Q into T1 minus T2 divided by T1, means T1 minus T2 divided by T1, means T1 is equal to 800 and T2 is equal to 400. 800 divided by 800 minus 400 divided by 800 equal to 50 kilowatt will be the output. Then question number 18, the coefficient of the performance of the heat pump is working on the reverse Carnot cycle is 6. The coefficient of the performance of the heat pump working on the Carnot cycle is 6. Here coefficient of the performance is 6. If this machine work at a refrigerator with a work input is 10 kilowatt, the refrigerator effect will be. Here coefficient of the performance COP is equal to Q divided by W. So COP is equal to COP of HP equal to COP of R plus 1. So total COP is equal to 6 minus 1 equal to 5. Here COP is equal to Q2 upon W. So COP of the R is equal to 5. We are getting 5. So Q2 divided by 10. Q2 is equal to 50 kilowatt. That's it.